Imagine you are standing outside, enjoying a warm afternoon, when suddenly the light just stops. Not like a sunset and not like a cloud passing overhead. It is as if someone simply flipped a switch on the entire universe. But here is the thing. For the first 8 minutes and 20 seconds, you wouldn't even know anything was wrong. You would still feel the warmth on your skin and see the blue sky as if everything were normal. This is because light and gravity do not travel instantly. They travel at the cosmic speed limit. But once that time is up, the reality of our solar system would be rewritten in an instant. The sun, the anchor of our existence, is gone. No light, no heat, and no gravitational tether holding us in place. We are about to go on a journey through the first hour, the first week, and the first year of a world without a star. And the science of how humanity might just survive in the eternal dark is more incredible than you think. To understand the immediate aftermath, we have to look at the physics of gravity. According to Einstein's general relativity, gravity travels at the speed of light. So, for those first 8 minutes, Earth would continue to orbit a ghost. We would be circling a point in space where the sun used to be. But the moment that 8-minute mark hits, the gravitational tether snaps. Earth doesn't just sit there. Instead of moving in a circle, we would suddenly begin traveling in a perfectly straight line, shooting off into the interstellar void at about 67,000 miles per hour. We aren't just losing our light, we are becoming a rogue planet, a cosmic wanderer launched into the darkness of the Milky Way. Initially, the most obvious change is the darkness. It's not just that the sun is gone, it's that everything else goes out too. The moon would vanish within seconds because it only shines by reflecting sunlight. The planets would disappear one by one as the darkness reaches them. Jupiter, Saturn, and the distant edges of our system would blink out of existence from our perspective. The only things left in the sky would be the distant stars and the glowing band of the Milky Way, which would actually look more brilliant than ever before because there would be zero light pollution from our host star. But surprisingly, the world wouldn't freeze over instantly. Earth is a massive object with a lot of stored energy. We have an atmosphere that acts like a thick, cozy blanket, and we have a molten core that generates its own heat. In the first 24 hours, the average global temperature would begin to drop, but it wouldn't be a catastrophic plunge just yet. It would feel like a particularly chilly autumn night everywhere on the planet. If you were in a tropical region, you might just think it's a weirdly long, cold snap. The real challenge wouldn't be the cold in the first few days. It would be the psychological impact of a sunless sky and the total failure of the global food chain. Photosynthesis, the engine of life on Earth, would stop the very second the light vanished. Within days, small plants would begin to wither. However, the oxygen situation isn't as dire as you might think. Our atmosphere is so massive and so saturated with oxygen that even if every single plant on Earth disappeared tomorrow, it would take several thousand years for the human population to breathe it all up. We wouldn't suffocate in the dark, but we would certainly start to get very, very hungry. As we move into the first week, the temperature starts to really dive. The average global surface temperature would drop to around freezing, or 0 degrees Celsius. In many places, this would mean the beginning of a permanent winter. The oceans would still be warm for a while because water is an incredible heat sink, but the land would start to become inhospitable. People would begin migrating toward areas with geothermal activity, places like Iceland, Yellowstone, or the volcanic regions of Italy and Japan. These are the places where the Earth's internal heat is closest to the surface. And in a world without a sun, the Earth's core becomes our new best friend. By the end of the first month, the average temperature would hit negative 20 degrees Celsius. This is where the world starts to look like a different planet. The top layers of the oceans would begin to freeze. This actually provides a layer of insulation for the water below, preventing the entire ocean from freezing solid for hundreds of thousands of years. Deep-sea life around hydrothermal vents wouldn't even notice the sun was gone. For them, the surface world is a distant memory anyway. They live off the chemical energy of the Earth, and they would continue to thrive as if nothing had changed. This tells us something profound. Life on Earth wouldn't end. It would just move. For humanity, survival would become a feat of extreme engineering. We would have to build massive, self-contained habitats. Imagine cities built inside giant greenhouses, powered by nuclear fusion or geothermal energy. We would have to grow all our food using LED lights, mimicking the solar spectrum. We would be living in a world of artificial light, where the rhythm of day and night is dictated by a clock on a wall, rather than the movement of the sky. After a year in the dark, the surface of the Earth would be at -70 degrees Celsius. At this point, the atmosphere itself begins to change. The water vapor has long since frozen out of the sky and fallen as snow. Now the carbon dioxide would begin to freeze and fall to the ground as dry ice. Eventually, it might get so cold that the nitrogen and oxygen in the air would condense and rain down as liquid, before eventually freezing into a solid crust of air ice. The surface of Earth would be a silent, frozen wasteland, looking more like the moon Pluto than the vibrant blue marble we know today. But humanity is incredibly resilient. If we had even a small amount of warning, or if we managed to utilize our existing technology quickly, we could move our civilization underground. The deeper you go into the Earth's crust, the warmer it gets. For every kilometer you descend, the temperature rises by about 25 degrees Celsius. We could build vast underground cities where the natural heat of the planet keeps us warm. We would become a subterranean species, mining the frozen oceans for water and using nuclear power to sustain our new civilization. Let's talk about the journey of the Earth as a rogue planet. Without the sun's gravity, we are traveling into deep space. The chances of us hitting another star or a planet are astronomically low because space is mostly empty. However, we might eventually pass through another star system. If we were incredibly lucky, we might be captured by the gravity of a new star. Earth could, in theory, find a new home. We would have to hope it's a stable star that doesn't flare too much, but the idea of Earth rehoming itself in another solar system is a fascinating mathematical possibility. In this sunless future, the stars would take on a new meaning. They would be our only landmarks in the infinite void. Astronomers of the future, living in their underground bunkers, would track our progress through the galaxy by watching the shifting constellations. We would truly understand what it means to be on a pet spaceship Earth. Our planet would be a self-contained vessel, carrying all the life that remains across the cosmic ocean. The ecological impact of the sun disappearing would be a massive reset. Most species on the surface would go dormant or simply fade away, but seeds can survive for decades in the cold. If Earth were ever to find a new star and thaw out, the planet might bloom again. There are extremophile bacteria that can survive the vacuum of space and the coldest temperatures imaginable. Life is persistent. Even in the most extreme scenarios, some form of biological legacy would likely remain on our planet, waiting for a new dawn. The sun is more than just a light bulb in the sky. It's the source of nearly all the energy that has ever flowed through our biosphere. Every bit of coal, oil, and gas we burn is essentially bottled sunlight from millions of years ago. In a sunless world, we would be burning through that stored history to survive. But we would also look to the future of energy, fusion power. The same process that powers the sun itself would be our ultimate goal. If we can master fusion, we can create our own mini-suns inside our underground cities. We would no longer be dependent on a distant star. We would be the masters of our own light. Think about the oceans. They contain the vast majority of Earth's heat. Even after years without sunlight, the deep oceans would remain liquid. Huge underwater cities could be a viable option. We could use the pressure and temperature gradients of the ocean to generate power. The ocean floor would become the most valuable real estate on the planet because of its stability and proximity to the Earth's internal heat. The surface would be a place of myths and legends, a frozen realm that few would ever visit. From a planetary perspective, the Earth would become a much more quiet place. The wind, which is driven by the uneven heating of the sun, would die down as the atmosphere freezes. The massive storms and hurricanes would disappear. The geological activity of the Earth, the volcanoes and earthquakes, would continue, driven by the decay of radioactive elements in our core. These would be the only Evlover events left. The shaking of the ground and the occasional eruption of magma into the frozen night. But what about the other planets? Jupiter and Saturn are mostly gas. Without the sun's heat, their outer layers would also contract and cool. But these gas giants have immense internal heat of their own. Jupiter radiates more heat than it receives from the sun. They would survive as glowing, warm beacons in the dark for a long time. However, their many moons would suffer. Moons like Europa or Enceladus, which have subsurface oceans, might actually be okay. Their heat comes from tidal flexing, the gravity of the giant planet pulling and squeezing them. Just like the life around Earth's hydrothermal vents, any life in the oceans of Europa wouldn't care if the sun disappeared. In fact, the outer solar system might be the most stable place to be in this scenario. The physics of a disappeared sun also brings up the question of what happened to the rest of the solar system's mass. If the sun simply vanished, the center of gravity for the entire system is gone. All the planets, asteroids, and comets would go flying off in different directions like marbles released from a spinning plate. The solar system wouldn't just go dark, it would dissolve. We would be part of a massive diaspora of rocks and ice, scattered into the galaxy. This thought experiment highlights how incredibly fragile and special our current situation is. We live in a perfectly balanced system where we are just the right distance from a stable star. We take the sunrise for granted every single day, but it is the fundamental heartbeat of our world. The disappearance of the sun would be the ultimate test of life's ability to adapt. We often think of space as a distant place we visit, but we are in space right now. We are on a rock moving at incredible speeds, and our lifeline is a giant ball of fusing hydrogen. In the long run, thousands of years later, Earth would eventually find a thermal equilibrium. The heat flowing out from our core would match the heat radiating away into space. This equilibrium temperature would be very low, but not absolute zero. We would be a warm-hearted but cold-skinned world, drifting through the Milky Way. If we were ever picked up by another star's gravity, the thawing process would be spectacular. The frozen atmosphere would turn back into gas, creating massive global-scale storms as the air returns to the sky. The frozen oceans would melt, and for a while the Earth would be shrouded in thick clouds of steam. Humanity, if it survived, would be forever changed. We would be a species that had looked into the true abyss and didn't blink. Our culture, our religion, and our science would all be centered around that moment when the light went out. We would be the people of the dark, the engineers of the deep, and the wanderers of the void. The story of Earth would no longer be about a blue planet orbiting a yellow star. It would be about the planet that survived the loss of its heart. It is also worth considering the accidental benefits. As a rogue planet, Earth might pass close to frown dwarfs or other large bodies that could provide heat through tidal forces. We might pick up new moons along our journey. The galaxy is a crowded place when you consider the trillions of planet-sized objects wandering the dark. We might not be as alone as we think. In the vast interstellar medium, there could be millions of other rogue planets, some of which might have their own civilizations living underground just like us. But back to the right now part. If the sun disappeared this second, the first thing you would notice after 8 minutes is the change in the sky. The stars would become incredibly crisp. The GPS on your phone would stop working almost immediately because the satellites rely on precise timing that would be thrown off by the change in gravity. The tides would change too. While the moon causes the most significant tides, the sun is responsible for about 1/3 of them. The oceans would suddenly shift, causing a global, albeit small, adjustment in water levels. Communication would be difficult. If the power grids fail due to the sudden drop in temperature and the loss of solar power, we would lose the internet. People would be left in the dark, both literally and figuratively. This is why decentralized energy and community-level geothermal systems are so important for resilience. The people who would fare the best in the first few weeks are those already living in extreme environments, like scientists in Antarctica or people in the far north. They are already equipped for the cold and the dark. The disappearance of the sun is a fascinating way to look at the interconnectedness of everything. We are tied to that star by invisible threads of gravity and constant streams of photons. It governs our biology through our circadian rhythms, our economy through agriculture, and our history through the climate. To lose it is to lose the context of our entire evolution. We are quite literally made of stardust, and we are sustained by a star's energy. But the science of survival is optimistic. We have the technology today to survive in a sunless world, even if only for a small percentage of our population. It would be a struggle, and it would require a level of global cooperation we have never seen before. But the human spark wouldn't necessarily go out just because the sun did. We would find a way to keep the lights on, to keep the air breathable, and to keep the story of Earth going. As we drift further into the void, the sun would eventually become just another star in the distance, no brighter than Sirius or Vega. We would look back at where we came from and realize that the sun was just a temporary guardian. The universe is a vast and sometimes hostile place, but it is also full of possibilities. If we can survive the disappearance of our own star, we can survive anything. We are a part of the universe that has become self-aware, and that awareness is a flame that is very hard to extinguish. So the next time you feel the sun on your face, take a second to appreciate the physics of that moment. Appreciate the 8-minute journey those photons took to reach you. Appreciate the gravity that is holding you firmly to the ground and the Earth in its orbit. It is a beautiful, delicate, and incredibly powerful arrangement. The sun is the reason we are here, but the Earth is the reason we could stay even if the sun decided to leave. The hypothetical disappearance of the sun teaches us to value our planet's internal resources. We often look up for our future, but in a crisis, we would look down. The molten iron in our core and the radioactive rocks in our mantle are a quiet, steady battery that has been waiting for billions of years. We are standing on a giant thermal reservoir that could keep us alive long after the stars have faded. In the end, the story of the sun disappearing isn't a story of the end of the world. It's a story about the resilience of life and the ingenuity of the human mind. It's about how we can take a cosmic catastrophe and turn it into a new way of living. We are a species of survivors, and we carry our own light with us wherever we go, even into the deepest, darkest parts of the interstellar void. The sun might be our father, but the Earth is our mother, and she has enough warmth to keep us safe for a long, long time. As the Earth travels through the galaxy as a rogue world, we would eventually become a mythic civilization. Future generations, born in the medium bunkers of the Earth, would hear stories about the great light that once ruled the sky. They would see pictures of green forests and blue oceans and find it hard to believe that the world was once so bright and so warm. But they would also know that they are the descendants of those who didn't give up. They are the ones who turned the Earth into a spaceship and set sail for the stars. The galaxy is full of rogue planets, and some scientists believe there might be more rogue planets than stars. This means our impossible journey might actually be a very common one in the grand scheme of the universe. We might be joining a silent fleet of wanderers, each carrying the embers of a civilization that once had a sun. If we ever encounter another rogue planet, it could be the most significant meeting in history. Two civilizations, both survivors, meeting in the dark between the stars. The universe is vast, and our time in the light of the sun is just a small chapter in a much larger story. Whether we stay in our comfortable orbit or launch into the unknown, the essence of humanity remains the same. We are seekers, we are builders, and we are survivors. We are the ones who make the dark a little less frightening by bringing our own light into it. So while the sun shouldn't just disappear, it's comforting to know that if it did, we wouldn't just vanish with it. We would move, we would adapt, and we would continue our journey through the stars, forever looking for the next sunrise, even if we have to build it ourselves. The human spirit is a star in its own right, and it shines brightest when the world around it goes dark. Keep looking up, stay curious about the mechanics of our cosmos, and remember that no matter what happens in the sky, we have the power to shape our destiny right here on Earth. Space is the final frontier, but the human mind is the vessel that will take us across it.